Okay, second example. Solve the equation z to the power of 4 equals minus 1. Now, first thing you notice was you will have 4 roots, like z1, z2, z3, z4, and it'll be equally spaced starting at z1 because it's unity. Okay, so if you don't remember unity, nth roots of unity is z to the power of n equals plus minus 1, which is one of them. Okay, and also what can we tell when it comes to unity? The sum of the roots is 0, and the complex roots will come in conjugate pairs if they're real. Okay, let's have a look. As I told you before, I'm going to push this up. So we know the 4 roots, z1, z2, z3, z4, will be equally spaced on argument diagram and starting at z1 and forming the vertices of a square because it's going to form a regular polygon. So if you got 4 roots that's equally spaced and equal length, you will get square. So first step, it will be to find the location of z1. Okay, so to find the location of z1, let z1 equals r. So we got to do polar form. So equals r brackets cos theta plus I sine theta. Okay, so next one, and we got z to the power of 4 equals minus 1, and left hand side is z4, which is in the polar form. I'm just going to write a polar form like that, and by de Moivre's theorem I will get r to the power of 4, but with the argument you just times it together, not the power. And the right hand side I've got minus 1, and to write this minus 1 in polar form I need to write it like this. So cos pi is minus 1 and sine pi is 0, so I'll end up with a minus 1. Make sure you use the argument, principal argument will be the minus pi and the pi. So just come up with the closest one. Okay, so I'm going to put them together as equal and equating them. Okay, so if I equate them, I'll get r to the power of 4 equals 1, which is that, and then 4 theta equals pi, and I can make the theta the subject, and r equals 1. Okay, so therefore my z1 is 1 brackets cos pi over 4 plus I sine pi over 4. Okay, so let's go on to the next one. Okay, I'll push this down a bit because I'll prepare the lessons ahead. So let's have a look. So the z1 is what we just saw. Now that means the other 3 roots will be equally spaced from z1. So if I divide it by 2 pi, because that's the circle is 360, which is 2 pi, and divide by 4 because there's 4 parts, so 4 roots, so it'll be pi over 2. Now z2 will be, the modulus will be the same. Cos will be static because z1 was a pi over 4. I just have to keep adding pi over 2 because that's how it's going to go spaced out. And that will give me 1 brackets cos 3 pi over 4 plus I sine 3 pi over 4 for z2. And z3 will be very similar, but this time from z2 we just have to add pi over 2 on each side, and I will get that. Now when you look at this, this is not agreeing with the principal argument because it has to be between pi and minus pi, and it's over pi. So what I'm going to do here, I'll change that using the principal argument. So if you don't remember, I'll just quickly draw the diagram. So 5 pi over 4 is from 0 to all the way here in a third quadrant, and that little part is pi over 4. So if you think about it, it's a 0, pi over 2, this is a plus minus pi, and down here it's minus pi over 2. So that little part, the passing, the pi is pi over 4. So to make it to pi, and it's going opposite direction, it'll be minus 3 pi over 4. So always remember, they need to make it pi, but direction will change opposite. So make sure you put minus 3 pi over 4. So that's what we got. And Z4 is just from Z3, I just have to add pi over 2, and I'll get minus pi over 4. Now if you're not really sure about the fraction, use a calculator, and then make sure you don't make silly mistakes. Okay, so I've got 4 roots. 4 roots, I've got all of those. Now if you look at carefully, the Z1 and Z4 is conjugate pairs, okay? And Z2 and Z3 are conjugate pairs. Because a conjugate pair is, it changed the imaginary part. So if I put this in the imaginary part, the cos minus pi over 4 is cos pi over 4 because it's even function. So plus minus doesn't really matter. But this one, this minus goes out. So do you remember conjugate pairs? A plus IB, the conjugate pair of that is A minus IB. So it's always changing the imaginary part. The sign will change that. So I can write it like this. Z3 equals conjugate of Z2 and so on. Now this happens because Z to the power of 5 equals minus 1, and that minus 1 is real. So when we have a real, the roots come in conjugate pairs, and also the sum of the roots equal to 0. So when you add all this together, of course cancel out, you will get 0. Okay, now I'm going to have a look at the diagram. Okay, diagram here. So first one, Z1 was from x-axis all the way. Argument will be always starting from the x-axis, and then it was pi over 4, and then it's spaced out pi over 2. Okay, so make sure you sketch it nicely and neat, and when you join them together you will get square. Okay, now here we got Z to the power of 4 is a minus 1. Remember we actually at the start we had a question, so I've just got that one here. So that's a Z to the power of 4 equals minus 1, and that Z to the power of 4 is 4 theta, isn't it, from the de Moivre's theorem, and that equals a pi. Okay, so that was sketched on there as well. So that from here to here is pi.